So I think you can hear me. Okay, great. Ladies and gentlemen, take your seats. We are going to start with this session on renewable energy and climate. I'm Thierry Ranchin. I'm working on this domain since some years. And so the scope is really to showcase the use of Earth observation for renewable energy and climate application. So you will see that this year we will more focus on solar energy, but also on some other topics about climate, and we will discuss some presentation about the renewable energy application based on Earth observation, some example, of course. And we will describe also the current evolution of the Copernicus Energy Hub, thanks to Fabio. And we will have an open discussion on the different topics linked with EuroGEO. So here is the program for the next hour and a half we have in front of us. And so I would like to give the floor now to Stelios Kazadzis, which is online. Stelios, I think the floor is yours. So we'll stop sharing the program and see the presentation from Stelios. Let's go on.
Okay. Hello, Thierry. Hello, everybody. I'm sorry I cannot be there today, but there was some problems tomorrow early in the morning, so it was difficult to travel.
Stelios, if you can speak louder. And
Yes.
also you are...
Yes. Can you hear me?
Yes, speak. From the Zoom, it's okay. I don't know from the room. I don't know.
Okay. Philip, you can hear them or? Can you hear me?
Yeah.
Okay, can you hear me now? Is it better? And can you see my screen?
So you have to switch the mode for us.
At the top, display settings. Change that.
So you have to change on the display setting.
Double presentation. Yeah. The display settings. On the top, on the left a little.
Okay, or you can stay with that and go with the usual mode of PowerPoint. Up to you.
Not sure that is Stelios. Can you hear us?
Yes, yes.
And do you hear Thierry as well?
Yes, yes. Now.
Okay.
Yes. Okay, so I'm going to present this first presentation. I'm Stelios Kazadzis. I work in the World Distance Center in Switzerland, and this presentation is together with Paris Congress and all the people that work towards this next sense application in the ESAPE project. The collaboration with the National Observatory of Athens, the Armin Paris-Tech, and also Transvalor from France. The main motivation about this application has to do with the global and international initiative for mitigation of climate change, and the more specific, all the let's say the initiatives that the ESAPE project has wanted to have application to include. And these are the UN Agenda for Sustainable Development, more specific the Goal 7 for affordable and clean energy, and the sub-sections about the reliable energy services, and also the increasing the share in the renewable mix. And the directives agreements like the Paris Agreement, the Repower Europe, and in addition to some initiatives that are linked with the ESA project, the GEO initiative for the Vision for Energy and the GEO Cradle initiative from EuroGEO. All this about has to do also with the evolution of the renewable energy targets from 22% in 2009 up to 45% in 2022, with the goal to reach this percentage in 2030. And in order to do that, the problem here is that the increase of demand for solar energy needs more efficient production and integration to the electricity grid. So also to try to minimize the cost of PV installation infrastructure. So the motivation was to find some fast and accurate, high spatial and high temporal resolution energy forecasts that can contribute significantly towards this goal. And from the science
Stelios, can you hear me? We don't hear you. Can you push the volume of your mic at the maximum, please? Or speak louder, because it's really difficult from the room to hear you.
Is this better or the same?
Not that much.
Yeah, where is your microphone?
Where is your mic?
The mic is in the computer, so okay, I will try to speak something like that. Is it okay? Can you hear me? Can you hear me?
From Zoom, we can hear you. I don't know if from the room, Thierry.
From the room, it's a bit soft. So if you can not shout, but speak as loud as you can, Stelios.
Okay, so
good.
So the scientific problem is to, in order to have some more accurate nowcasting or forecasting of solar energy, is for different time scales, you need to understand the atmospheric conditions and mostly clouds and aerosols. And this was the scientific challenge for this application. And the last point is that it's important to try to utilize these European Earth observation resources, especially Copernicus related. I will talk more about it, and provide this innovative and mature products. Now, a little bit about the system. The system works with inputs from different sources. One is the Copernicus Atmospheric Monitoring Service, and I'm talking about the nowcasting system now. The second one is data from climatologists and other data, aerosol data from the Sentinel satellite. And the last one is the cloud product of the MSG instrument in the UMETSAT product. So this nowcasting system has a feature of pre-run 7-dimension radiative transfer model, and also it has a new, let's say, parameterization of the cloud optics. And the output of this system is global horizontal irradiance and direct normal irradiance at all sky conditions in real time, every 15 minutes that this cloud image is coming, and also spectral data from 300 up to 3,000 nanometers for Europe, Middle East, and North Africa. This system has been evaluated in some publications, and using ground-based data from the baseline surface radiation network, with quite nice results from different kind of places and conditions. And then during the last year of the ESA project, this application has been upgraded to also to the short-term forecasting system, which forecasts the solar radiation in the next from 0 up to 4 hours. So in order to do that, there was a new, let's say, module, a cloud motion vector module that was in addition to the previous nowcasting system. And now using this forecasting for clouds, if you can estimate the solar radiation for the next few hours. This whole application is now in this kind of site that you can scan. This is application for the short-term forecasting aspect. You can see that clicking somewhere, this is a picture from last week, 29th of September. Clicking in any point here, you can see a box of 5 by 5 kilometers. And then immediately you can see how much is the solar radiation now, how much it will be in the next 3 hours, and how much it has been in the past 2 hours. And this is the point here in Italy, that some clouds are approaching. So even if there was a very nice day till then you expect some kind of less solar radiation in this area. Then in terms of users, this was developed in order to have the transmission and distribution operators for national or private developments and plants. And the expected user community, it has to do with grid operators, power and electricity corporation, ministries, energy trading, researchers, and also down to the let's say building level. The supporting infrastructure to do this is the GeoCradle and Beyond at the National Observatory of Athens collaborative ground segment for satellite data, and also computer infrastructure. And as I said, the partners, in addition to the World Radiation Center and the National Observatory of Athens, was Armin and Transvalor. Now this next sense, in addition to what I already said, has different kind of aspects. It uses past data for various databases or databases that extract from itself, from the past, in order to explore and define solar potential for specific areas, nowcasting and short-term forecasting, as I described. Also long-term forecasting using numerical weather prediction models for the next 1 to 2 days. And in the end, the spectral data can be used for health applications like UV index, DNA damage, and vitamin D. And this is for the UV region. And for the visible region, it's the photosynthetically active radiation for agriculture. If I go through a little bit fast one by one, the first one about fast data exploitation has been used with users from the Ministry of Renewable Energy and Electricity in Egypt, the actual ministry, that asked for the solar atlas of Egypt and asked also the characterization of some national areas in order to build photovoltaic parks, in addition to a Hart Foundation Center in Aswan. Then the nowcasting project was used in different aspects. One was this application for Cyprus, within one European project, Excelsior, to understand the global horizontal and DNI radiation for Cyprus. Also, it was analyzed in an economical kind of sense for this Makti Yacoub Hart Foundation in Aswan, in terms of the effect of dust aerosols for the area and the economic effects on the potential photovoltaic park there. And the third one was some publications related to the use of another geostationary satellite that focuses on the Indian Ocean. So there was an analysis for India. Then for the short-term forecasting, there was the Greek National Power Transmission Operator called the IPTO, and also the Public Power Corporation Renewables, which is a SME based on the Public Power Corporation of Greece that have used during the ESA project this application. Now, for the long-term forecasting, there is also in the same site that I showed you before, there is an application for the Greek area. This was used again for the Public Power Corporation. And you can see here that clicking in real time in some of the major cities in Greece and some of the major photovoltaic, let's say, parks, especially national parks, you can see what's going on today and the next 2 days for this area in terms of solar energy. Again, for the UV, so using the spectral data, there was this application that was used from the some ferries during the vacation time, during summertime in Greece. And again, the application in the same webpage deals with clicking at some major cities in Greece, and you can see the forecasted for the next 2 days UV index for this city. Some the way forward, let's say, about science, cloud and aerosol forecast improvements have to be implemented in general based on this triangle of model, satellite, Earth observation, and in situ data. There is now this Destination Earth EU initiative with a lot of data, homogenized data going together as a EUMETSAT and ECMWF data lakes, as they are called. So this is a digital innovation, highly important potential for solar and wind applications. There are user-oriented applications. A very important aspect is site adaptation. So we can use this kind of models, but if you are focusing on one specific area, someone can also build on using in situ measurement, historical data, artificial intelligence techniques, also probabilistic methods in order to improve this model in a kind of very user-oriented area. And then, of course, there is always scientifically the trade-off between scaling up an application and the model accuracy. So the model adaptation to the infrastructure scale can also have improved accuracy. Another important aspect about the users is to try to demonstrate and convince the stakeholders that the importance of the model accuracy, where a few percent of improvements can equal a high profits for this multi-billion renewable, let's say, future. Now for EuroGEO and renewable energy strategy, there is this GeoVenner and also this GeoCradle initiatives that we have discussed that they need some kind of reorganization, and this energy action group towards some very targeted, let's say, actions in order to define some roadmap for the sustainability of all these applications that were developed through this CSA project, and to design some future joint actions. And all this trying to address various aspects of the Green Deal, the European Initiative Green Deal, European Union energy legislations, and agreements, including the United Nations standard SDG goals for clean energy. Thank you very much, and sorry about the technical problems.
Thanks a lot, Stelios. Any burning question on the room? Or we can have the series of questions at the end, and we'll have a discussion there. Okay, so thanks a lot, Stelios. Stay with us, and Philippe, I think the floor is yours.
Thank you, Thierry. I'm sharing the screen. You should see something already. And I can... Okay, so do you see my screen? Yes, it's okay. And you hear me? Okay, so hello everyone. My name is Philippe Blanc. It's a pleasure for me for doing this presentation. Thank you for the organization and the invitation. So I will talk about high photovoltaic penetration at urban scale. And it can be seen, and it has been developed in the same framework of the E-Shape project as Stelios, and can be seen as the same, we are sharing the same solar resource needs, but at a different scale, at a finer scale, which corresponds to the urban scale. So I won't go into details about the context. It has been already introduced by Stelios, and more specifically for the urban scale, we can mention that there is the European European Solar Rooftop Initiative, which is part of the solar energy strategy of the Europe and Repower EU, of course. And the idea is to push and to accelerate the PV rooftop installation with a series of measures that limits the length of the time. And the idea is that there is potential of 25% of the EU electricity consumption from the solar rooftops, which makes sense. Okay, why it makes sense? Because in urban area, it's very interesting to have these PV systems, no emission of pollutants, no direct emission of pollutant of greenhouse gas during the exploitation of the PV system. The production of electricity is done exactly where the electricity is consumed, and it corresponds to more than 70% of the population of Europe in cities. And it can add value to unused urban roof, parking shades for commercial centers, etc. So having a better understanding of the solar resource, its variability and solar cadastre in space and in time, we will see, provide information to that enable to analyze the solar potential of roof and shades over city compared to the local electricity consumption, and it helps public and private decision makers and investors. So solar cadastre is not new, and for example, we took part of the first solar cadastre in France, at least in 2016, and it provides free, accurate, and easy to use tool for general public to assess the solar potential of rooftops PV systems. So it has been done with the French National Mapping Agency, IGN, Mines Paris, and Soda Transvaal Innovation at the time. So it was solar mapping at high resolution, but computed once and for all only for the roof, so corresponding to the buildings, and only at an annual basis for the solar radiation. So in the eShape project, we had a pilot dedicated to high PV penetration at urban scale. And the objective was to provide GIS tools dedicated to high PV penetration based on Earth observation for two parts of the pilot, and one will be presented by Marion afterwards. The part one was about the PV variability at urban scale. It was the pilot. It's about Earth observation data to have a better modeling of the urban energy system dedicated to PV integration. Okay, so our vision during this project is to go from static solar cadastre, we used to, and we developed the algorithm for that, to dynamic solar assessment and forecasting at urban scale, dedicated to urban scale, but on the fly, using Earth observation. So it's not anymore pre-computed solar map at high resolution, only giving multi-year, yearly, or monthly yields. But the idea is to compute on the fly over a zone of interest that is free to select. It can be a roof, but it's open to other places, and to promote and support PV penetration cities. And the fact is that it provides not only maps, but time-resolved maps intraday up to 15-minute resolution with a spatial resolution of lower than 1 meter. And the basic idea of this dynamic solar assessment and forecasting is to be based on the cloud and to have as a service solar assessment and forecasting. So cloud-based, on demand, on the fly, scalable. So if you want to have, you can invoke different servers to have the requested amount of power computing to provide the service. And it's input agnostic because everything is based on interoperable an open interoperable system with standards of web processing services. So we can manage to use a different source of information from and this type of information. And the idea is, provided that this information can be delivered in the same way as interoperability and is a request, then we can use this information to provide the service at urban scale. So what are the Earth observation data? So first, we basically we are using CAMS, Copernicus Atmospheric Monitoring Services, dedicated to radiation. So it's based on Heliosat-4 methods developed by DLR, FMI, and MinPari, and also images from Meteosat second generation. So we are also providing information about the clear sky state of the atmosphere, integrating aerosol and water vapor. And you can see here an example of dust events that went through the France, and you can see the effect of this dust event. It's not cloud, it's aerosol. And this is accounted by the model, and it's very important for cities at certain scale. We are limited by the scale from CAMS radiation, from CAMS aerosol, sorry. But you can have some information, and we have demonstrated that in some places, it makes sense to use this aerosol data in city to provide this variability induced by aerosol. And if it's possible and available, we can use in situ parametric measurements to do the calibration for the long-term series of satellite data. We are using also digital elevation models. So, for example, from SRTM, but also DSM, digital surface model, standardly provided by airborne system with orthophoto images or LiDAR data. And this is an example of, this is the premise of MinPari in Paris. You can see the buildings, you can see the trees, you can see some part of the buildings, the different heights. So you can see the complexity of the shape of the urban at the urban scale, and we can compute in a very fast and efficient way the mask that occults, that prevents the direct radiation from the sun to arrive on a given square meter of interest. So from this E-shape pilot, for which we have made some developments, cloud developments, acceleration, efficiency, etc. We did also some co-design to try to see what would be the end users and how to adapt our outputs, our way of presenting the data, computing the data for different users. And at the end of the E-shape project, it came out, we can think about MinPari PSL spin-off that is under construction. The name is Solar Disrupt. And the idea is to provide bankable solar data at urban scale as a service. So it provides some features, free selection of area of interest, not only rooftops, parking, roads, facade, vertical facade as well. Multi-annual time series up to 15-minute time resolution. And it can be less if we interpolate the results. Analysis of PV self-consumption. If you compare this time series of area of interest, you can put a PV system. You can compare term per time with the energy consumption, electric consumption. Analysis of PV fleet injection in the urban electric grids with or without storage, because you have time series, historical data, so you can see the conjunction, the occurrence of conjunction, etc. And so to define the grid for to be able to accept this PV outputs. Analysis of impact of new buildings. So you have a PV system already in place, and you have a new building, and you can assess the effect of this new building on the PV yields. And you can also, since it's you can do short-term forecasting of urban PV fleets for electric spot markets. So you can see here the team that are involved in the possible spin-off Solar Disrupt. You have Nicolas, Lionel that is already in the room, and Benoit, the computer science guy, and Etienne Vey also for this spin-off. And this is a static solar cadastre that you can see, for example, from Google. You can see the shadow at yearly basis here. Yes, no, sorry, it's a daily basis here, but you have this type of information. And of course, having the time result information, you get time series for each pixel here, and you can here, you have a zoom here, you can see the details you can have with this type of computation. And if you imagine the PV system at this part of the roof, then you can here have the POA, what we call the plane of array irradiance coming to this place, and then it's rather easy to make a simulation of PV outputs. Okay, so you can see this the interest of this, and by the way, this has been computed in let's say minutes of time computation with the proper server on the cloud as a service. Thank you very much, and maybe there will be some discussion or question afterwards.
Thank you, Philippe. Any burning question? Yes, we have one.
Yeah, I was wondering in terms of adoption, I was wondering if there was any plan to convert, I mean, the maps you have into money. Could you aggregate, you know, it's okay, if you put a solar panel based on, because you also have the price of energy in real time. Could you take for 1 year and have, okay, if you use solar panel for this area, this is how much you would make money? I think this would very help convince people to say, okay, look, this is how much your rooftop is worth for 1 year.
Yes, and you're right. Here we are providing complex outputs, and it's the reason why we did some co-design to derive from valuable information. And indeed, for some application, here it's an example of just irradiance, so it does not talk to everyone, but we have derived some outputs, and more particularly for PV self-consumption. Indeed, you can, for a given place, for 1 year, you can have a simulation and say, if you have a PV system there, then you will save this amount of money, because you can have your own electricity that is definitively at lower cost as the one that you would import from the grid, and it will be even more contrasted with the time, because we all know that the electricity will be costly and coster. Sorry, I don't know the term, but expensive, more expensive with the time. So we can derive some very money-based, if you want, for talking to people. Yes.
The short answer was yes.
Yes, sorry.
No, it was a complete one. Thank you for that. Thank you, and so we are going to the next speaker. So Miko.
So, but good afternoon, I can say anyway. So if the slides are not up yet. So the Arctic is my topic, and how sustainable energy is challenging for the Arctic, but also, of course, the way to go. And this comes from a project of Arctic Passion, where there's actually no specific work on sustainable energy, and some things that we do at the Finnish Meteorological Institute. I think very important to understand, especially for the European Arctic, hydropower, so energy production, is actually one of the main exports of this area to the south. So there's usually something like fishing for the Norwegians, forestry in Finland, and then tourism in both cases. But the number 3 in all countries in the Nordics are pretty much that the energy is an export good, and it usually comes from hydropower, some comes from others. But what is challenging for this is that it's not anymore so foreseeable as it was before, because the snow amounts in winters are really changing more than it was usual. So sometimes we have huge amounts of snow, then we have small amounts of snow, and all of that is something which they try to predict better and better. We have done, and this is something where E-shape is still also shown, so a former project for EuroGEO that we try to really make that snow power, so how much power potential is in the snow pack, make that a service. Can you, there's this one window, can you move that from my slides away? On the left side. There's this small irritating window, please take it away. Anyway, so Jaakko Ikonen and Jamal Tanis have made this hops.fmi.fi service for the biggest hydropower operator in Finland. So they have 21 dams, if I remember correctly, in this one river delta where several rivers flow into one. Kemi River, big one in the end. Kemijoki Oy is the company name, so it comes from the big river name. All kinds of parameters are there, but I think the interesting fact is now the seasonal forecasts is, I think, where it then boils down to what energy business is many times about. The Nordic countries have all their energy market in one place, so it's a bidding and buying stock exchange style work, and to be really releasing at the right amount your energy is crucial. So they really want to understand for a longer time forward already how it goes. We have had really nice success with machine learning forecast models to be able to do this even for a long period forward. When it comes to this hydropower thing, what is also again something that's because of climate change is a little bit fluctuating more is that we have these ice dams and then the ice situations in the let's say river and lake systems in Finland at least are challenging, but even for that, so we just had a new graduate thesis student last year. She made so Golda Prakasam, she made a nice product for us for ice jams, so that when we in Sentinel-1 images just check all the pixels for rivers and lakes, we can say where there is ice and where not, and especially we can also distinguish when it's damming, all that ice gets less flat, it's like getting together, that you can find those pixels out of there. But then the lake ice service that our colleagues in Syke are doing in Arctic Passion, for example, that's also a good knowledge of this, because when there is ice, this still is when can they flow, what they do in those hydro dams is a little bit restricted. Then we go to wind power. I think that's the biggest trend in the Nordic countries. So Sweden and Finland are kind of like the hydrogen promise that all the industry will from and it's a very good thing for climate change kind of mitigation purposes, that we will not anymore kind of burn any natural gas or let's say other kind of fossil fuels, but we will use hydrogen for the smelters, for all kinds of like hot stuff is needed, that it's actually hydrogen burning, and the hydrogen would then be produced by actually clean wind energy. So that's why there's quite a boom in Finland. I think they have been doubling the wind power produced in just 3 years or something. So it's like super rapid. You can, in the Finnish map, the gray points are the newest ones, the green ones are already in operation. I think you can see that, especially the Arctic regions, which start somewhere, is there a, so Arctic is somewhere, Rovaniemi, about here is the Arctic Circle. So especially in this area, it's really growing. But I put here the Sami culture, or like the indigenous peoples area in the picture as a yellow one. You see that there's not that much in Finland, but in Norway especially, they are also very active there. And it's difficulties sometimes to, reindeer herding is what they mainly do as a business. And well, it has been shown, and they have been in court been liable for it, that wind parks are kind of keeping the reindeers away. They don't like that. So in that sense, it hurts some of the economy, but it's so interesting that even in Norway, they are getting more inland from the, let's say, coastline power production that they have until now. But this is kind of super huge, and definitely we have many more times energy production in this area when we are actually using it there. So I think some cities it was like 3 times more produced when they consume themselves, something like this or even more. And I also put a little bit the North American Arctic in there. Very few wind power production sites, but in principle very similar the let's say winds and things. So there's lots of potential in this. One particular problem maybe in North America more than in our part of the Arctic is permafrost. So that when frozen ground is a lot underneath on which you would have to build. Nowadays they make so high wind powers, let's say constructs, and they are very heavy. So the risk on permafrost to do it is pretty big. So even if I think those power plants are mostly 20 years or so, they are not forever. But even in this time frame, to be able to say something about permafrost is interesting. Arctic Passion has actually a permafrost change detection system, but it's more used for in this case, in Longyearbyen, Svalbard, Spitsbergen, where they have the buildings in this Longyearbyen town. Some of that has big changes. You see that housing is those things quite close to it. So really that things are changing in this respect, and they had one culture, let's say building, they had to lift it up, put some new kind of like deeper poles in, and they did even a cooling system under the house. So they lifted the house, put a cooling system under, so that the permafrost under the building keeps normal. Pretty drastic stuff. But this is something where some progress is in Arctic Passion being done, that we try to find out what can be done, and Earth observation is a wonderful tool for those. Then specific, the image on the bottom shows you that biomass burning is still one of the really important ones, and these are just the big power plants. So all the houses usually, so residential things like log burning or like wood is everywhere used, also in Norway. So this is a very bad picture that they wouldn't do that. But anyway, that biomass burning and tree-based energy is actually a super important, let's say, factor, and it is pretty much okay, kind of, let's say, climate change-wise, because we have also a very quickly increasing growth of trees in this area. So probably can, at least for looking at this area, can have a positive impact on the climate change as well if you use this type of energy. And it's not just energy, they do all kinds of stuff from the trees nowadays. So the plastics, for example, will be replaced, or can be replaced. They are just a little more expensive than fossil things at the moment, but I think those things we will have to take on board. And biofuels, so biodiesel, the parts that are being now mixed into the gasoline that we have in Europe, that comes from these biofactories as well. And we have for a long time now had harvesttheseasons.com, which tries to not just make that part that the material is going to help climate change, but we also try to make the environment better with this. So the trafficability of the big machines that harvest forests, we do a service for them. Just had a poster outside, so 7 persons came to look at it. Thank you very much. Solar power. I knew you would have so much of it. I only have this one small slide, and on my last slide, actually a little bit. In the Arctic, snow is a very big thing. So I think it was over half of production can be lost because snow is going to be on top of those. So some kind of snow removal things are probably needed, and it's not necessarily good what they did here on the wall. This one, it just is very clearly less productive. Oops, where did I go? Yeah. Okay, I can find the right one. Now I'm not in control anymore. Yeah, but to continue, so those kind of on the wall where the snow can't stick, then they are like 30% or 40% less productive in the good times, and well, then there's not that long as a winter condition that it is viable to do it like this. But the Arctic is, in that sense, for all the renewables, in a way, still something, because residential solutions very much use solar power. It's usually because many places are only used in the summer, and then you only have sunshine, so anyway, perfect. And production is the best in the world at that time. One interesting thing that doesn't work well, or at least analysis shows it to be a little bit bad, that tidal, so both wave and tidal energy is kind of not easy to reach, and a solution based on that for sea area. This is for monitoring networks, if they could use the wave energy. Best energy would be in something where the difference between the ice slates moving on the sea and the sea could be somehow used, but that gets very difficult at the moment. And sea ice in general is the problem. For sea ice, in Arctic Passion, we have a service where for the ship classes, we already do an analysis where can which, so polar code is something where ships are being set in what kind of ice situation are you allowed to move. And it's of course useful to both analyze. So that picture is showing where are which class areas. So the red ones is no one can go, and here are different classes can go. We also have that as forecast systems. But let's go quickly to the conclusion, because I think two cool things from machine learning, which I'm very much involved in lately, and it relates to Philip's talk a little, just by weather forecasting information being related to observations that we have done. And so the Finnish energy network is really nice that it provides all the data on a very fine grain for different production modes in Finland. So we have been just using the past years and all the weather information from all of Finland. The machine learning model immediately beat the Finnish FinGrid, so the operator of the general network, for us to forecast how much, what kind of production comes out. So, which we actually have been also turning into the energy prices are very volatile in the Nordics. So this has been used for informing if it's going to be expensive or if you can earn money by consuming. I have nowadays also a deal where I can have minus prices, so then I have to put the sauna on and you know, get wild. Yeah, but I think Arctic and sustainable energy is actually cool. Thank you.
Thank you, Mikko. Any burning question? No. So I think the next speaker, Fabio, the floor is yours.
Thank you, Thierry. So I would like to introduce with this presentation the progress with the Copernicus thematic hub on energy. Maybe some of you were here this morning for the session on health, and so some slides are the same, but anyway, the voice was not very good, the connection, so repetita iuvant anyway. So the thematic hubs, the concept of the thematic hubs is to provide another dimension to the services of Copernicus. So we have the traditional Copernicus services organized around the science domains, so climate, atmosphere composition, marine services, and so on. We have the dimension of the national collaborations, which I don't have to discuss here, but it's very interesting because as we discussed also in previous days, not all the data are useful for everybody everywhere. So there is this national dimension in terms of policies and much more. And then there is the dimension of the application areas. So for instance, a sector like energy, or it could be health and others. And The thematic hubs have the main goals to provide a single entry point to Copernicus services that provide products and information and services specific for that sector, for a specific sector, and they provide the simplified access. And then there are, of course, other goals, like, for instance, provide inspiration on integration with different type of data sources. So the climate change service is in charge of developing and maintaining the energy hub, and the atmosphere monitoring service is in charge of the health hub. We try to cover all or many of the aspects of the energy sector, from production of renewable and non-renewable energy to transmission, distributions, efficiency, consumption, emissions, and so on, including also energy security aspects. So the idea is that then we get, we are in communication with all the Copernicus services. We try to understand with them what products and services can be useful for a specific sector, in this case energy, but not just Copernicus. Actually, we will connect also to other data sources that are useful, for instance, from satellite agencies. And also, for instance, ECWF is moving more and more towards open data, so there are data that can be integrated from the core products of ECWF and the Horizon Europe project. The users on the other side are some of them are already we already interact with them. Some we will interact. So there are the DG, the policy DGs of the European Commission, member states, international European institution, international organization, WMO and GEO, and private sector and more. The idea is then is the Energy Hub connects, let's say, the Copernicus offering, provides this single entry point to the Copernicus offering to these users. The concept of the thematic hub has been created by the GDFI, and there is a role for the Knowledge Center on Earth Observation to be the link between these services and the policy DGs. And there is also an advisory board that I will talk about in a minute. So by talking with the services and users, this is the first, let's say, set of products, information from different Copernicus services that we believe are useful for this sector. We started with the climate change service, unsurprisingly, also because it already had a sectoral information system working. But of course, we heard already in previous presentation, for instance, the use of the CAMS data, but also emergency service as they provide river discharge, for instance, and so on. I talked about the advisory board, so this is the current composition of the advisory board, and basically their task is to advise on the promotion of how the thematic hubs can help in the promotion of the use of Copernicus services, connection with the users, and how they can also inform on the evolution of the Copernicus services. This is the current composition. However, that doesn't mean that it's fixed. And in fact, I discussed with Thierry already a few days ago and yesterday as well, that perhaps there is a role for EuroGEO, for instance, in some shape or form to contribute to this, and maybe other organizations as well. So the idea with these thematic hubs is that we add a layer of intelligence, so we try to understand by knowing who the users are, what they want and what they need. And in this case, for instance, we talk about the policy DGs, international organizations, and so what they want to do. The reasons why they need this data is to support policy need, decision making, and to plan and develop power system. And what we can offer is quality control data. We can offer tools, applications, but also inspiration, ways that this data can be combined together to provide the services that the user community needs. And there is here a case with IRENA, the International Renewable Energy Agency, that has developed a global atlas for renewable energy, where users can overlay climate data and population density data and other types of data. So, and that can be help for various reasons. For instance, for feasibility studies in site-specific areas for photovoltaic or wind power. This is the way that at the moment the hub appears is a website, basically, with links to resources, a catalog of data, and user stories. It's a beta version. It's under development, really, and it needs more engagement with users. It would be, for instance, very interesting to have additional user stories, successful user stories, to inspire also other users on the way to combine data and to build applications. And it will have also grow with more data sources. The catalog will grow, and also in general, user engagement. And it will be launched on the 7th of November at the EU Space Week. And this is all I have to say. Thank you.
Thank you, Fabio. Any burning question? Okay, so Suzanne, the floor is yours, and then we will have a bit of time for discussion.
Yeah, so I will present also again eShape and Destiny A use case from renewable energies in DLR. So we have two models we are using for these issues. We have on the top the FlexiGIS. So you can see on the totally right. Where's the presenter? Here. Here will be the Earth observation data included. Here we have then some load profiles or standard load profiles. And in the end will be some optimization, and we can also see if our input data have an effect on these issues. The second model is Remix. I will come later to it in detail. So why we are using this two models, we want to support potential users like grid operators, private persons, researchers, industry, and decision makers in urban planning. So as Philippe already said, we had the second part of eShape in cooperation with Mines Paris. So the first part is our data collection by our airborne data set. So we have some night lights, we have some hyperspectral data and some optical data. We post-process them with the colleagues from Remote Sensing Technology Institute. And the second part, we use the development of Thierry and Philippe's group and using the time series. What come out from all this post-processing and this time series, we can use inside FlexiGIS to have some optimization output, so we can see how the different types of renewable energy be optimized for the georeference data. So in eShape, we implement some CAMP radiation data sets. We generate from the airborne data sets digital, yeah, it's easier. Some digital surface models. So we extract the height information and the roof top angles. Also the building footprints, so the outlines of the buildings, all in 20 centimeter resolution. And additionally, we are using the Korean land cover from our colleagues in Oberpfaffenhofen. Inside FlexiGIS, it's used PVLib. There's the calculation for only one single system at the moment. It's using also ERA5 data, and this was enhanced with some CAMS data. So we combined ERA5 data with the CAMS data. And we are also on the way to have some PV multi-location processing from the airborne data. But it's still ongoing. As I told you, we have the single system at the moment, and we're extracting from the airborne data the really PV shapes, and also have the eye-to-sky network. I also will come later to that. What we will include now to the same series, and for some test rooftops, we have 21 PV systems, what we are used. And we could see an impact if we enhance the ERA5 data with CAMS data. All those is also in a graphical plugin for QGIS. And both models you can also download from GitHub. So they are now available open source. Our results in this topic was that we can see an impact of the different type of data sets. So in the left, you see the OSM data sets, and you see many gaps inside. And the folder cover with current data sets, and you can see that you have some overestimation from the OpenStreetMap data to the Earth observation data here. And the simulation was done for the electric demand by standard load profiles. So now I come to the Destiny Earth use case. Here we are developing a demonstrator for climate information used in energy system applications. These data sets from Destiny should be ground-based validated on eye-to-sky. This will be also a comparison of several meteorological data sets we will see later, and model sensitivities on that. As mentioned before, tools and method development for climate scenarios in energy system workflows. And we have this as cooperation between European grid operators, public authorities, and stakeholders. So in Destiny Earth use case, we are working together with Aarhus University and Renewable Grid Initiative. So now I come to the eye-to-sky. This is our unique all-sky imager network. So it's measuring solar irradiance by global, diffuse, and direct components. So you can see here on the left is the camera, and then you have some diffuse measurement. You have the direct measurement here, and some no. This is the direct measurement, this is the diffuse measurement, and this is the global measurement. But don't be such detailed with me, because this is more or less the work of a colleague. Additionally, we are measuring temperature and relative humidity. And this eye-to-sky network is used for cloud monitoring. So the camera is making each 30 seconds an image. And we can have a spatial resolution by 5 by 5 meter. Our actual processing is on 20 by 20 meter resolution. We can forecast with this in high accuracy up to 20 minutes, and overall time up to 2 hours. So in the complete right side, you see such an output of some generated irradiance map. The dark point is the darker part here in violet is some clouds, and the yellow areas is some, let's say, clear. So, and the demonstrator should be the remix model. So we will use at the moment existing open source datasets, and in this project, the ongoing implementation is Destiny Earth data to validate the weather forecast models. So Remix has different inputs like different energy demand or technologies. What is inside the model be combined between heat and power, hydrogen, transport, and such issues, and have some output and optimization for hourly system data or in the infrastructure capacity expansions. So the first results we see here is an output from the Remix compared to the Pan-European climatic data set. So we have on the left, we have the base, and we can see for the University of Reading and from Renewable Ninja datasets, the difference for four characteristical weeks. So we can see we have different energy sources, and depending on the data set, we have an impact on those. So what we can say for conclusion, so we need an intensive co-design with the application and library developers. So we need to make a really deep adaptation in the FlexiGuess code. In FlexiGuess, as I said already, we implemented several EO data. The previous system detection is still ongoing. And yeah, we can see in both models we have some impact of EO data, or if you use geophysical data sets, yeah, and the application and data evaluation is still ongoing. And if you need some more detailed information, feel free to contact. That's it.
Thank you, Suzanne. So, Miko, if you want to join, Fabio also, Philippe and Stelios, I hope you are still online. So we have a few minutes for discussion. We run a bit of time, and there is a session with poster. But I tried to have a series of questions inspired by your different presentation. So, as you know, we are in the EuroGEO Workshop. So this means that the EuroGEO aspect is underlining a lot of our work. And so, as you know, there is this 3C strategy from EuroGEO, which is coordinate, combine, and cooperate. And I would like your point of view on how we can contribute to this as a group working on the energy, and how it fits to the strategy to support this activity, thanks to the different things you present. So, up to you. Yeah. So you have to.
Miko goes somehow push. Now it's on. Well, very simply. So the Arctic Passion Project, some of those activities which were not super directly related, but I think in the Arctic Geos. Is it an application, how it's called, when you go into the geosystem? We have already mentioned that we are collaborating with GeoVenair. So in that sense, kind of on the geo level, we are doing it, but of course it would be nice to be more concrete, maybe also on some actions in EuroGEO. And there I must admit that I'm not aware of them, but ready to do them. I think that's not at all the issue. So we just need some kind of places and things to do for. And I would say that energy hubs or stuff like this is actually a very good place to kind of like, where do we present each other is anyway, I don't like the EU projects. Every project drive up your website, try to make it like fancy and live, and then 5 years and then it's gone. Very stupid. So I think in a way something like the energy hub for Copernicus or similar things, I don't mind necessarily what it is, but it would be actually nice if we try more to combine to a like ongoing service the things that we do in projects, and not so much that every project has to. Even Arctic Passion is a great name, so hey, it's like don't want to lose that. But in essence, the basic concept I think is not so good for a long time effect of things. So that's why there's something that I see.
Thank you, Mikko. Online, Stelios, you underlined some topics on your conclusion. Maybe you want to intervene on this point. How we can support the EuroGEO strategy through the combine, coordinate, and cooperate aspects.
Yes, I think DaySafe gave a very good opportunity to develop and to demonstrate and to co-design these applications. A lot of very useful applications, and it would be a pity not to have some kind of coordination towards some EuroGEO specific goal. Otherwise, this application, some of them will survive, some of them will not survive. Yeah, that's my point.
Thank you. So, Philippe, you want to add something on that? No.
Please say no.
Please say no. So come on.
I don't know. I don't know. For the moment, I don't know.
Okay, Fabio, I think.
What is it? There is nothing here.
It's just on.
All right. I thought there was a button.
Yeah, it seemed like
I would like to make very similar remarks as I did this morning at the health session. That is very good that we can have this coordination with Copernicus and the activities between Copernicus and EuroGEO. And also I would like to say that perhaps it would be nice to have a continuous communication within these sectors, like it could be health, it can be energy, that go beyond the organization of these events, these workshops that are 2-3 times a year, but what happens in between, so what is the community doing in between, so like having tools like perhaps newsletters or blogs or way to keep the community informed about maybe also changes in policies at European level, something that the community can engage in.
Yeah. Okay, thanks. From the room, any comment on this topic, or if you have ideas or things you want to share on this? If not, I have a series of questions. Yes, Philippe?
So now I have a question. I have a suggestion as well. So I fully agree that we should go beyond some sparse events and to be more connected. And maybe a way to be more connected is to engage students, because we know that students are interested. Some engineering students or PhD students may be very interested in contributing to the climate and energy transition. And so having coordination about students, the way they can move from an institution to another in the network can help us to have a better relationship between us. So a bridge through the students, PhD and engineering students.
Thanks. Yes, Suzanne?
Yeah, I also want to agree with Mikko. We need something what will finance longer time, so that we, if we have some product or some development, that we can also use it for extensions for development. If you start with some ground or basic research, then for sure you cannot do it in 5 years to a final product. And The second thing, what I think is also important, that we might also have a look to other applications. So let's say from traffic or from health, or what he also said, that we have a look where energy applications is also used or needed.
Yeah, thank you for the comment. And clearly, when you are looking to the spectral distribution of the solar energy, there are a full set of applications in agriculture, in health, also for the UV and so on. So I think there is also this interlinkage with the different type of thematic area that can support also the benefit of EuroGEO. So if I saw also in the different presentation, Stelios was acting also a bit on the action group. We have the GeoVenner initiative, and there is also the Copernicus Energy Hub, which is starting or growing. And so I have also a question about what are the complementarity, what are the place of each of these tools, and how we can organize their own activity on that. I think, Fabio, maybe you have an idea on that. Stelios also maybe. So, Fabio?
I think it's to be thought and discussed. Certainly, for instance, a representation of EuroGEO in these thematic hubs to guide and advise on how they can develop. That I think it's very useful. Perhaps the other way around as well. So from thematic hubs to EuroGEO, like we are doing now, this morning, and now presenting the progress with it. With GeoVenner, I think what is probably important, interesting also for Europe is to go outside of Europe and try to, somehow also influence development outside Europe. So this connection with GeoVenner could be useful, or any other, initiatives at global level.
We have an example with Arctic Passion also, yes.
Yeah, but I would be very practical also on that thing that Fabio in a way talked about, that the information, what is getting done where. I think we usually have to do blog posts or some kind of things. We can easily simply can release them in many channels. So like we can put them on the Energy Hub, they can be on the Arctic Passion side, they would be on the Arctic Geo side, and still it's the same news. I don't think it hurts at all that we are practical in these terms and not try to, but this is ours and this is ours, because it's much more important that all of that information finds any route it can find to users. So I would start on that very basic level of communication, because then that actually makes you more day-to-day aware of the others. I think that's a very useful thing, especially when something new comes up, to integrate that. That is, I think, an important factor. But then at some point it's probably good to do joint actions. I have actually actions in FP Cup with Chile, which are all energy related almost, because it's exactly the like PV production in Chile is interested for some things that we can do, and then it's let's say air quality related things, which does have in the background that a lot of the energy production or things are bad there, and the air quality is. So I think there are many links together where CAMS, for example, is a useful tool in two directions and not just one. We have been kind of like in helping them there to get things done, but I think this is where all over the world, I think there is this opportunity that we are already giving them some basic data, but I have noticed from the Chile example, we actually are active in Africa as well, and in other countries in South America, that there's still kind of like a certain step of being kind of like not ready enough to just jump in and try and use things, but it's more like that they want to build a trust relationship from this to the data through an organization or something to do together. And for that, it will also be useful to kind of like kind of share that what we are doing between each other, but then it also helps to bring those examples of where we are, and then it's very practical, some of these. So we had a hackathon there, so these are startup kind of things who would probably have good partners in Europe to actually kind of develop their own thing, but maybe then also get get a market somewhere else.
Okay, thank you. Stelios, you want to add something on this?
It's more, I just want to add some more organizational stuff, and I copied something from another session that it talks about this, how to achieve this, joining this kind of actions. It just says that in this other section today in the morning, addressing climate-induced disasters, there is a point that says that designing future joint action, policy papers, publications, special edition in journals, workshops, webinars, information days for application and services, with support of the EuroGEO Secretary relevant CSAs. I think it's a good bullet to start with. I mean, it probably is very general, but I would agree also with what Philippe said about including this educational aspect and students in this kind of activity, because it's I think it's important. I agree with Philippe on that.
Okay, thanks a lot. So maybe I have an additional question, which is not very. So let's try it. So what are you waiting from EuroGEO? Oh.
Are you looking at me or what?
No, I'm looking to
yeah, please look at the other first.
Susan, what are you waiting from EuroGEO?
Oh, good question. I have to think about it.
Okay.
Well, I think one simple thing is, of course, that how does EuroGEO, for example, help us to get funding to do some of these things? Mm-hmm. It's, I think, one of the very key questions. Like, GEO in Europe has always lived by the fact that there's actually some project funding available then to put those ideas into actions. We are definitely now on the thing that I find my money somewhere else, and if I'm nice enough, I come to EuroGEO with it. And if I don't care, I don't. So I think this is unfortunate, and I must say one of the things is Destination Earth, Copernicus could be both, and I'm actually involved in both of those, so it's also like bashing myself in a bit, but the fact that we could also be a little bit more kind of helpful to acknowledge that this thing is something that we should all work towards. So that when we do Copernicus actions, when we do Destination Earth actions, let's show those actions in the GEO world as well. And I think the route is through EuroGEO. So the integration of action groups in EuroGEO with actions that we do in Copernicus, I think it's very natural that somehow these need to be connected and have kind of like, meetings a few times a year at least. But I think this is then that it should become something where each other bring something, and I think the GEO part is to really, how can we like inform the world of what happens in Europe, because I'm also the GEO principal of Finland, so it was really horrible in Ghana when you are there, and even all the data that we do is presented by the Americans as something that they call something else, like or as Australians, even worse, I think. Well, no, it's not worse, but in fact that they have, yeah, but they present things that is probably mostly Sentinels, or it's even reanalysis from ECMWF, and then it's like all called just whatever Africa something. So they have several of these actions where they just rebrand it nicely as Australia helps Africa or USA helps Africa, and then I'm like, wow, you're really kind of boring in the fact that you don't acknowledge and thank you Europe for the data, because that's actually the case. And that's why I think it is in that sense when we are doing, for me at least, from my point of view, we do most of the first spearheading into new things for the whole world, happens in Europe nowadays, Earth observation wise, modeling wise, everywhere. And it's so stupid that we then don't use the GEO world, because it's not so easy in our world that we engage with Africans. We don't engage so much in other parts of the world, but GEO is the one where we could do this at least. And that would help to kind of like
branding and being more visible from the rest of the world.
They would come to ask from us directly, and they wouldn't go to Australia to ask for help to use European data.
Okay.
And I like Australia, so no problem there. But in essence, just this is a good example because they are so far away. That why not us be on the spot for this when we have mostly done it?
Okay, thank you for the comment.
Too
So
much,
Fabio,
also, I guess.
any?
Yes, I would say that that this role of EuroGEO to be an intermediary with the wider geo community is a very important one. I would say that within Europe, probably the use of Copernicus data is well established. I mean, of course, you can do much more, but yeah, probably what is can be massively improved is the use outside of Europe, and possibly this could be stimulated also with some actions. I was talking before about the National Collaboration Program. That also helped about the use of Copernicus data in Europe. But I wonder whether there is a way to extend this concept outside Europe, especially in developing countries, and whether there is a possible help with the DG on international partnerships. So whether EuroGEO could mediate with the developing agencies in Europe to support the use of Copernicus data for development projects outside Europe.
Thank you. Philippe, Stelios, you want to add something on this?
Yes, if it's okay, Stelios, can go. Okay, so I see EuroGEO as many things, because it should be a network for us to work together. It should be also a community to engage people to use Earth observation, and I think that there should be also a way to be connected to other networks. I am thinking for the domain of solar energy, for example, to use the EuroGEO to be connected to PVPS, for example, and to have this connection. We can do it individually, but it has a stronger effect if we can make this interrelation at a level of EuroGEO, at least for solar energy, for example. Yes, so community network, and yes, and something about the funding of research and funding for young researchers and students.
Thank you. Stelios, you want to add?
No, I don't have anything to add. Yes, I think it's fine.
So I have a full set of questions, but I think we are close to the end of this session. So I want to thank all the presenter about what they present and all the discussion we have. But I think it's still continuing in the coming day, weeks, months, and so on. So thank you very much again. And I think it's time for the poster session, and you can also enjoy the coffee. Sorry for you guys, but we will have coffee now. Bye-bye.
The next poster is upstairs. So I still need to see for asking questions.